Okay, let's talk about how to debug your mod. So for the purposes of demonstration, I will be debugging how bullets fire, which will be in this function, cbaseNid fire bullets. And I'll scroll down to where the magic happens. So here we are at the place where the game actually figures out where a bullet lands. So exactly the best way for you to debug a problem is going to depend on what that problem is, but I'll go over all the major ways to debug a problem. Generally, the most easy way to debug a problem, not necessarily the most robust or efficient way to debug, but certainly easy, is just print something to the console. To print something to the console in source, you want to call a function called MSG. And then in here we put a string to print, and we'll just put fired bullet. And you have to put a new line in order to make it actually print on its own line. Otherwise, whatever prints after this will just end up right next to this line, and it'll be like fire bullet, fire bullet, fire bullet, fire bullet, blah. You don't want that. So just put a new line there, and let's go and try that out. So yeah, you can see every time an NPC fires one of those guns, we get the message in the console. And we can do this with our own gun. You can't really see it there, because it just kind of, it's the same thing. Let's go to a different map. And there you go. But notice that we're only seeing 4 messages here for a shotgun blast, which is not right because a shotgun fires 8 pellets. And that's because of this here. This makes it so that half of a shotgun's shots will fire differently. They will be tiny boxes instead of just straight lines in space. So we can just go and add our message to there as well. But it's not really a good idea to have 2 text messages that print the exact same thing, because then it's hard to tell which one is which. So we'll call this one fired box bullet. And yeah, there we go. But notice how these are not printing very neatly. Like these 2 here are switched around. What's up with that? Well, that's just because Source's console sometimes just does a little goofy like that. Why? I don't really know. But there is a way that you can deal with this. So what we can do is just print a number so that we know the real order of the messages. And we can just include a number in our text message. So let's go here and let's add on %i. And then we add another argument here, which is this iShot variable is the I variable for a for loop. And for every shot that we fire, this number will tick up 1. And we can do the same there. So let's see. Well, in that time, they printed exactly in order. 0, 1, 2, 3, 4, 5, 6. Okay. Let's see if we can get an attempt where it's out of order. Okay, it just doesn't want to do the bug anymore, I guess. Whatever, you get the point. Some people have also told me that you can set this console variable matq mode to either 0 or 1, and apparently that somehow fixes that bug where things will print out of order. I don't really know why that fixes that, and I don't really know if this is a good way to fix it, but apparently that is an option. The kind of variable that you want to print to the console the type of that variable needs to match what you put here. Like, this is an integer, so I put in I here. If this was a float, then I would put F instead. And since floats will usually have like a long decimal, you can put 0.1 right there, and it'll make that decimal place be not as precise. It doesn't actually change the variable at all, it just prints less of it in the console. You may also have seen red text in the console sometimes. Probably have. That is done by changing MSG to warning. And sometimes, since the console can get a bit spammy, you can also do dev MSG to make something print only when the developer console variable is set to 1 or higher. Having developer set to 1 is also how you get this text in the corner here, which is just the same text that prints in the console, just, you know, on your screen. Might make it a little easier for you to debug something. And there is also dev warning, which is the red text, but only when developer is set to not 0. There is also something called con color message, where you put a color as a argument before the string, and in here you can specify exactly what color you want the message to be, including alpha. This will make it print in pink. And this is just RGBA, red, green, blue, alpha. There we go. But usually people don't use this. It's just not really worth the trouble of making a color and all that. But, you know, maybe if you're really into it, I don't know. But sometimes text is not really that helpful. Sometimes it's a lot more useful to actually like visualize what your code is doing, and with text you just can't really do that very well. Like in our case, what if we wanted to see that, like, just, you know, the exact path that a bullet went on? Well, there is a way to do that. So first we go and debug overlay, and we call line, and then we put in where we want the line to start, which will be where the bullet started, and where the line ends will be where the bullet landed. And then we put in 3 numbers for a color. I'll make it orange, so a lot of red, a bit of yellow, and no blue. And then next we have something called no depth test. If it's false, the line that we draw will act like a regular object in 3D space, and if it's true, the line will render on top of all other things. I'll set it to true just to show you what that looks like, I guess. And then we have duration. This is how long in seconds the debug line will stay in place. You can set this to -1 to make it last only a single tick, which is useful for some certain things that will change very often, like every tick, and you want that line to update very frequently, but not in our case. I'll set that to just 10 seconds. There you go. I don't really know if this is going to show up well in the video. Woo, that's a lot. Hello? How are you firing like that? Why? Why would you do that? Anyway, but once again, remember that the shotgun works a bit differently. We're only seeing the non-box bullets there. So let's add something up for here too. Now, there isn't really a good way in Source to show exactly how a box trace sweeps forward, you know? But we can get a decently close visualization. First, we'll copy that over, but then we also need something to show the boxiness. And what I'll do here, change this to box. Oop, box. Okay. So now for a box overlay, we want just one position. And I'll make that the place where the bullet lands again. And then what do we want? Oh, right, the mins and maxes. So mins and maxes mean like the minimum coordinates and the maximum coordinates of a box. In our case, it's just this right here. And then let's just keep the orange theme with the colors. And then for boxes, you can also specify how filled in you want the box to be. I'm just going to keep that. Well, no, let's do 100 just to demonstrate what happens. And then duration 10 again. There we go. Now, obviously, a hole trace will actually have the entire width of that box the entire time, but there's just not really a good way to demonstrate that in Source. It's fine. I mean, you could make one, but there just isn't one natively. Maybe I'll make that a video. Sometimes visualizing a problem doesn't really help, and sometimes text is not too helpful either because it's just inefficient. So sometimes what you need is a debugger. Now, if you're coming here from my previous video, I already showed you everything that you need to do to set up the debugger in Visual Studio. But for anyone who did not watch that video, go to your client project and go to debugging. And in here, you want to go to your exe that you downloaded from Source SDK Base 2013. This one. It has to be the one in here. It cannot be the one from Half-Life 2. If you use the one from Half-Life 2, you'll run into some problems that you just don't want to deal with. If you're on the multiplayer SDK, then use multiplayer's exe instead. And yeah, put that in there. And then for the command arguments, we want to add allow debug, novid, and game with a path to your mod folder. And you will want to do this for your episodic project as well if you have one. So now go up to here and select debug. So let's talk about what this is. There are two modes that you can compile your code in. There's debug and release. Debug is a mode that makes it easier to debug your code, but as a side effect, the code will run slower. And release is the opposite. It runs faster, but it's not as easy to use a debugger on that code. When you're, just working on your code and trying to, debug it, you want to use debug mode. But when you're actually sending your mod to other people, you want to use release mode. Now, what do we do with a debugger? A debugger will let you stop your code at some certain point in its execution, and then you can view every single thing that you can think of, basically. So, for instance, I will press F9 on this line, and it makes this little dot here, and this is called a breakpoint. So, what that does is, well, you'll see. let's just go ahead and build.
The car's all ready for you.
Alright, so an NPC was about to fire a shot, and well, technically it's in the middle of firing a shot now. And yeah, we stopped at where the breakpoint was put, and now we can see a bunch of different data about all of the variables that are in play. Like, where does the bullet come from? It's coming from that place. This output tab is just the same as the console mostly. There's some other stuff in here, but whatever. Anyway, the important thing for the debugger is the call stack tab. This will show you all of the functions that led up to where the program is executing. Here we can see we're in a function called npc fire, and that calls a function called fire, and that calls fire bullets, our function from before. See? So I'm going to use this now to show you how we can see like what a bullet hits. So the trace function has not actually executed yet at this point. So up here we have 3 buttons called step into, step over, and step out. Now if I press step into, we'll actually go into this AI traceline function. The code will execute up until that point that it's actually executing inside that function. The AI traceline function is actually just a different name for the usual util traceline function. And yeah, now you can see that we're actually going inside that function. And I can press step over to actually go through every single individual line of that code. And when changes happen to the variables, you can see them highlighted in red. And finally, we can use step out to go back to the function that called the one that we're currently in. See, now we're back to fire bullets. The continue button will make the program resume execution at its normal rate. And now we can go and see what this bullet hit, for instance, which is this. And see, world, that is the world spawn entity. So whoever fired that bullet was not a very good shot. Another thing that you can do with a debugger is set up asserts. Asserts are basically these expressions that you can put in your code, and when those conditions that you specify are not met, you can stop the code and debug it immediately. So intuitively what we're saying here is we're asserting that the entity that the bullet hits is an NPC, and then anytime that it hits something that is not an NPC, we'll stop the code execution right here, and you can look at it in the debugger. It's not very useful, obviously, it's just an example. Something that you might do more commonly is like put in some kind of expression for something that you expect would always be true. For instance, like, we should always be hitting some entity, right? That would make sense. Like, if we're not hitting anything, then what's happening in that case? Like, even if you're shooting at the sky, your bullet should hit the world spawn. So let's go and try that. No assert because we are hitting something. But now let's just go out of the map completely. There, see? We're getting an assert message, and if we hit retry here, yep, same thing as before with the breakpoint. Now, if you make this a capital A instead of a lowercase, you will get a different assert dialog. And yeah, this is the one that you'll usually use. This one's obviously a bit more robust than that other one. And yeah, I don't really need to go over these options. They should be self-explanatory. On its own, when a program is in debug mode and it runs into some kind of fatal error that causes it to crash, you can also use the debugger to see what was happening at the point of the crash. Like, for instance, in the case that there's no entity, then this is null, and you're dereferencing a null pointer, which is one way to crash the game, and I'll show you what happens. Yeah, so when there's no entity that the bullet hits, we crash. And same as before, we're back to all of the debugging stuff. And in this case, since we're actually causing a crash, we get a little message here telling us that this was null. The next section is about infinite loops, which is when a program gets stuck executing the same bit of code over and over again. A debugger cannot be sure if a loop will ever actually finish executing or not. This is called the halting problem. And in some situations, an infinite loop is actually desirable. For these reasons, the debugger will not stop when an infinite loop occurs, so the way that you debug an unintentional infinite loop is a bit different. And I've created one such here on this map. And there you go. In this case, what you can do is go up here to the pause button, and then you can try to debug from here what might be going on. Let's out here. Can you keep this out, please? Okay, well, yeah. Sometimes you will end up in kind of weird places when you use the pause button, and there will be files like those ones that you saw there that you don't have source code for. You just kind of have to work around those, try to figure out what's going on without seeing the source code for those. It's very unfortunate, but that's just how it is. So, yeah, what is going on here? Well, I mean, obviously we do know what actually is going on. I've set these two entities up to constantly fire inputs to each other, but you know, like try to think about it, like what might give it away in here. In case you ever have this like actually happen to you, just try to like look around in what is causing the loop. Maybe use continue and pause multiple times and just see where you end up each time, and just look around different places. If there's any debug information, like here we have this, then make use of that. This is, if you put a number before dev message, you can specify what value developer has to be. It has to be at least 2 in this case for this message to appear. So yeah, let's just go and do that again while we have developer set to 2. And then we go to the output tab, and yeah, we can see it's just sending the same inputs over and over.